provides information about some of the insect and disease pests that can affect trees in the southeastern part of the United States. Let's begin with bark beetles. There are over 600 species of bark beetles in the United States. Bark beetles belong to the subfamily Scalidinae, formerly their own family of Scelididae. Many of these species are known to burrow into the phloem of dead, dying, or living trees. Many species are helpful in breaking down dead or dying trees. Many bark beetles are most commonly considered a pest of conifer trees. They generally attack trees that are under stress. They tunnel under the bark of the host tree, creating S-shaped galleries. This damages the tree's vascular system, which interferes with the movement of the essential nutrients and water throughout the tree. Bark beetles are capable of killing a tree in less than 1 year if left untreated. The species most commonly found in the southeastern United States include six-spined LPS beetles, pine engraver beetles, eastern five-spined LPS beetles, small southern pine engraver beetles, southern pine beetle, black turpentine beetles, and red turpentine beetles. Bark beetle description. Eggs are laid in the S-shaped galleries. They are very small and oval-shaped. The eggs are shiny and pearly white in color. The eggs hatch into larvae that are small grubs, 2 to 7 millimeter in length, about the size of a grain of rice. They have cream-colored bodies with reddish-brown colored heads. The larvae develop into pupae. They are small, white to cream in color. The pupae are in the S-shaped gallery as they develop into adults. The adults are small beetles, 2 to 4 millimeters in length. They have short legs, and their bodies are cylindrical shaped and reddish-brown to black in color. Both the larvae and adult bark beetles damage the host tree by their feeding activity. Bark beetle life cycle. Bark beetles have 4 life stages: eggs, larvae, pupae, and adults. Bark beetles in the southeast usually produce from 6 to 10 generations per year. The male beetles bore an entrance hole into the tree and excavate a gallery in the inner bark. The adult beetles mate in the galleries. Females lay eggs in the gallery that hatch into larvae. As the larvae feed, they create additional galleries in the inner phloem of the host tree. The larvae develop into the pupal stage. The pupae turn into adults. The adults bore exit tunnels out of the tree that creates a shot hole in the trunk of the host tree. After emerging from the host tree, the adults fly off and attack another tree. Bark beetle symptoms. Symptoms of bark beetles may include discolored foliage that changes from green to pale green to yellow to brown in a few months, leading to dead and dying branches. S-shaped galleries under the bark. Peeling sections of bark caused by the galleries. Shot holes and pitch tubes in the trunk that are created by the emerging adults. Eventually, if populations are high enough, death to the host tree can occur if left untreated. Management and timing. Bark beetles can be managed by microinjecting Abicide 2. A fall injection provides better distribution of product throughout the tree. Remove damaged and dead trees. Maintain the health and vigor of trees by providing water during dry weather. Abicide 2 is available in 2, 3, and 4 milliliter capsules and 1 liter bottles. The next pest is the emerald ash borer. The emerald ash borer is a flat-headed borer in the Buprestid family that feeds exclusively on ash trees. It is currently in many states in the eastern and midwestern United States and continues to expand to the west and south, wherever ash trees grow. In this map from January 2021, the light green areas represent the approximate range of ash. and the dark green areas represent ash distribution. The red dots are areas of emerald ash borer detection. Although primarily in the east and north, it is currently in parts of the southeastern United States also. The emerald ash borer has 4 life stages: egg, larvae, pupae, and adult. The larvae is a flat-headed borer. It can be up to 1.5 inches in length. It is cream-colored, flat with bell-shaped segments. The larvae have a reddish-brown colored head. The larvae feed in the xylem of the host ash tree. The adult is a beetle. It is 3/8 to 1/2 inch in length. The photo of the adult emerald ash borer on the penny is a good representation of its size. It is a very bright metallic green color. Emerald ash borer life cycle. The emerald ash borer usually has 1 generation per year. They overwinter as larvae inside the ash tree. In the spring, they pupate inside the tree. From mid-May through late June, the emerald ash borers emerge from the tree as adults. The adults feed on the foliage of ash trees during the day. After mating, the females lay eggs that are deposited individually in bark crevices on the trunk and branches. Females can lay from 65 to 90 eggs. The eggs hatch into larvae in 7 to 10 days. The newly hatched larvae chew through the bark as they burrow into the tree, where they feed on the phloem and outer sapwood. The larvae go through 4 instars, getting progressively larger in size. They continue feeding into the fall until cold weather. Emerald ash borer symptoms. The feeding larvae create serpentine galleries under the bark. The galleries disrupt the movement of nutrients and water throughout the tree. D-shaped exit holes in the bark of the tree are created by the adults as they emerge from the tree during the spring. Epicormic sucker branch growth may occur. Dead and dying branches in the canopy, followed by the eventual death of the tree, will occur without an effective management program. Management and timing. Emerald ash borer can be managed by microinjecting imicide in the spring, after the ash leaves have reached their full size, to provide season-long control as a preventative treatment. Microinject with Stemix Plus in either the fall or spring to increase vigor. Prune and destroy dead and dying branches. Keep trees healthy, reduce stress, and maintain adequate irrigation during summer. Imicide is available in 2, 3, and 4 milliliter capsules and 1 liter bottles. Stemix Plus is available in 6 milliliter capsules and 1 liter bottles. Hemlock woolly adelgid. Hemlock woolly adelgid description. Hemlock woolly adelgid adults are aphid-like insects belonging to the hemipteran order of true bugs with piercing, sucking mouthparts. Both the crawlers and adults are very small and difficult to see with the unaided eye. Their white woolly masses on needles are easily identified on the branches at the base of the needles. They feed on all species of hemlock. Hemlock woolly adelgid can be found from northern Georgia up into southern Maine. They have recently been found in western Michigan and northeastern Ohio. Hemlocks in any area of the country are a potential risk. Hemlock woolly adelgid life cycle. In North America, hemlock woolly adelgid are nearly all females. Males are winged and can be found on spruce, but their biology is not well understood. Hemlock woolly adelgid have 6 life stages of development, starting with the egg, followed by 4 nymph instars before reaching the adult stage. Hemlock woolly adelgids have 2 distinct generations per year. From early summer through mid-spring the following year, they go through an estivation period in which their development slows. presumably due to predaceous activity from other insects. Their spring generation is from early spring through midsummer, and development is much faster than the winter generation. Hemlock woolly adelgids may be identified by their white, woolly masses that protect the eggs. The white masses can be found at the bases of the needles. Eggs hatch into nymphs or crawlers. The nymphs go through 4 instars before they become adults. Nymphs insert their piercing mouthparts into the bases of needles and feed on the tree's stored nutrients. They remain at the base of the needle for the rest of their lives. The nymphs develop into adults that continue feeding on the host hemlock tree. The wingless adult adelgids lay eggs in the white, waxy wool that they produce. The spring generation produces both wingless and some winged adults. Hemlock woolly adelgid symptoms. The symptoms of a hemlock woolly adelgid include white woolly masses on branches, gray tinted needles. Needles turn yellow, brown, and drop from the tree. Branches die back. Death to tree after 4 to 10 years of infestation is highly likely if left untreated. Management and timing. Hemlock woolly adelgid can be effectively managed by microinjecting with dinoside or imicide as soon as new growth begins in the spring to provide a season-long preventative control program. Or microinject with dinoside or imicide when an infestation is detected as a curative treatment. Dinoside and imicide are both available in 2, 3, and 4 milliliter capsules and 1 liter bottles. Lethal bronzing disease. Lethal bronzing disease description. Lethal bronzing disease is caused by a specific type of bacteria that lacks cell walls called phytoplasma. The bacterium causing lethal bronzing disease affects over 20 different species of palm trees. Lethal bronzing disease can be found on the Florida Peninsula, parts of Texas, and Louisiana. Lethal bronzing disease cycle. The lethal bronzing pathogen is transmitted primarily by the American palm cixeid, which is a plant hopper. The pathogen lives in the phloem of the infected tree. It interferes with the movement of essential water and nutrients in the tree's vascular system. Lethal bronzing disease symptoms. The symptoms of lethal bronzing disease include premature fruit drop. The calyx end of the fallen fruit will be brownish to black in color and wet in appearance. Flower necrosis. Blackened flowers. Discolored foliage beginning with the oldest foliage that is closest to the ground. Collapse of the spear leaf, indicating death of the heart of palm. Death to the infected tree can happen within 3 to 6 months after symptoms appear. Treatment and timing. Microinject with Mauget Ultra, an antibiotic for preventative disease management and/or disease symptom suppression. This will require 3 to 4 injections per year. Monitor the area for diseased and dead trees. Remove all dead and infected trees. They are a source of the pathogen. Control sap-feeding insects such as leafhoppers and plant hoppers to reduce disease transmission from infected trees to healthy trees. Microinject Ultra is available in 6 milliliter capsules and 1 liter bottles. Lethal yellowing of palms. Lethal yellowing of palms is a disease caused by a similar bacterial pathogen as lethal bronzing disease, but they are distinct bacterial pathogens. A few palm species are susceptible to both pathogens. Lethal yellowing of palms description. Lethal yellowing of palms is also a bacterial disease caused by a phytoplasma pathogen. At least 37 different species of palm trees have been documented with lethal yellowing. Originally, the geographic range of lethal yellowing was limited to the southern third of the Florida peninsula. Recently, it has been confirmed as far north as Gainesville, Florida. Lethal yellowing of palms, disease cycle. Like lethal bronzing, the lethal yellowing disease pathogen is transmitted from tree to tree by the same plant hopper, American palm cixeid, as it feeds from the host tree's vascular system. The pathogen lives in the phloem of the infected tree. It interferes with the movement of water and nutrients essential to the tree's survival. Lethal yellowing of palm symptoms. The symptoms of lethal yellowing of palms can vary between the different species. Some of the most common symptoms include premature fruit drop. The affected fruit is brownish-black in color with a wet, water-soaked appearance. The normally cream to yellow-colored flowers are partially or totally black. Flower necrosis. Foliage of the infected palm turns yellow in color, beginning with the oldest, lower foliage progressing upward throughout the crown. Infected palms usually die within 3 to 5 months after the first appearance of symptoms. Management and timing. Inject the antibiotic Mauget Ultra for preventative disease control and/or disease symptom suppression. This will require 3 to 4 injections per year. Monitor the area for diseased and dead trees. Remove dead and infected trees to reduce the source of the disease. Control sap-feeding insects to reduce disease transmission. Mauget Ultra is available in 6 milliliter capsules and 1 liter bottles. Whiteflies. Whiteflies description. Whiteflies are not technically a fly. They do have wings and are capable of flying. However, whiteflies belong to the same order of insects as aphids, mealybugs, and insect scale. They have piercing, sucking mouth parts and feed on the sap of host plants. Whiteflies can transmit some plant viruses. Whiteflies can occur almost anywhere in the United States, but are particularly a problem in areas that have mild winters, such as Florida, Texas, and California, where they can breed year-round. There are hundreds of different species of whiteflies, with over 70 species in the southeastern United States. The species that commonly cause problems include citrus whitefly, ficus whitefly, ash whitefly, rugosa spiraling whitefly. Whiteflies description. Whiteflies affect over 500 species of host plants. Some of the most common ornamental tree hosts include ash, avocado, chinaberry, fringe tree, honey locust mulberry, privet rosebud, and various palms. Whiteflies life cycle. Whiteflies have multiple generations per year. They are capable of rapid reproduction in the summer heat, which intensifies their infestations. Adults are tiny white flying insects. Adult females lay eggs in a circle. Eggs hatch into nymphs in 5 to 7 days. Nymphs feed and go through 4 instars in 2 to 3 weeks. Egg to adult development happens in 4 to 6 weeks. Whitefly symptoms. Heavy whitefly infestations can easily be seen. They congregate on the underside of leaves and swarm in clouds when the infested plant is disturbed. Some of the other symptoms of a whitefly infestation include leaf yellowing, curling and malformation of new leaves, premature defoliation, wilting, and stunted plant growth. Whiteflies also excrete honeydew that can develop into sooty mold. Management and timing. Whiteflies can be managed by microinjecting either abicide 2, dinoside, or imicide in the spring to provide season-long control as a preventative treatment, or inject as a curative program whenever the infestation is detected. Abicide 2, Dinoside, and Imicide are available in 2, 3, and 4 milliliter capsules and 1 liter bottles. Micronutrient deficiency. Although it might not technically be considered a pest, let us spend a little time reviewing micronutrient deficiencies. In order to grow and maintain their health, plants have nutritional requirements. Macronutrients are needed in larger quantities and include nitrogen, phosphorus, hydrogen, oxygen, calcium, sulfur, and magnesium. Micronutrients are needed in smaller quantities and include boron, chloride, manganese, iron, zinc, copper, and molybdenum. Micronutrient deficiency description. Micronutrient deficiencies are common in many different tree species, including red maples, pin oaks, birches, palms, sweet gum, and other trees. Micronutrient deficiencies can be due to a lack or excess of certain nutrients in the soil or because of pH-related issues. Micronutrient deficiencies are usually an indication that the soil is too alkaline. Plants prefer a soil pH between 6.0 to 6.5 because that is when most nutrients are chemically available for root uptake. Sometimes high levels of manganese can cause magnesium deficiency. The photos here are just 2 examples of how nutrient-deficient trees may look. Micronutrient deficiency. Micronutrient deficiencies are also likely to occur in soils with low organic matter content. These soils can lack the ability to hold mineral nutrients. Organic matter also acts as a buffer for soils that have a highly acidic or alkaline pH. Nutrient deficiencies can also occur in coarse-textured sandy soils. They do not have the nutrient-holding capacity of a soil that has a higher content of clay or silt. Areas that receive heavy rainfall can have micronutrient deficiencies because rain is leaching the nutrients out of the soil. Deficiencies can also occur in heavily manipulated soils, such as in agricultural settings or areas with soil fill. Palm trees frequently grow in these soils and weather conditions. Effects on trees. Nutrient deficiencies can result in trees failing to grow and become properly established. Lack of available nutrients leads to a reduction in the photosynthesis process, root development, leaf production, and leaf expansion. Flowering can also be reduced in ornamental trees. Nutrient-deficient trees are under stress, which makes them more susceptible to damage from insects, diseases, and other environmental factors. Symptoms in broadleaf trees. Micronutrient deficiency symptoms in broadleaf trees cause many uniquely different symptoms, depending on the plant and the deficiency. Some of the more common symptoms include leaves that are light green to yellow in color, chlorotic. Necrotic spots on leaves. Leaves that are smaller, narrower, and more pointed than normal. Shoots that are smaller in diameter than normal. Symptoms in conifer trees. Micronutrient deficiency symptoms in conifer trees can also cause uniquely different symptoms. Common symptoms include needles that are light green to yellow, chlorotic in color. Branches and needles extremely stunted in growth. All of the needles except the first and second year needles have dropped. Terminal branch dieback. Symptoms in palm trees. Micronutrient deficiencies in palm trees are usually due to a specific nutrient deficiency. The symptoms in palm trees frequently appear on the oldest leaves first and progress to the youngest leaves. Some symptoms of a deficiency include a golden to yellow color of the petioles and bases of leaves, leaves with mottled, yellowish, translucent spots. The edges and tips of leaves may brown in color. new growth can be deformed or reduced in size. The tree's overall rate of growth can be decreased. Compromised root systems. A compromised root system may contribute to a micronutrient deficiency because the root's ability to take up nutrients has been impaired. Roots may be compromised by several different factors, including injury, root disease, poor site conditions, drought, soil compaction, and/or water-saturated soils. Management and timing. Microinjecting nutrients directly into the tree provides nutrients to the tree very quickly and bypasses the soil and roots. A micronutrient deficiency may be managed by microinjection of either Stemix Plus, Injectamin Manganese, or Injectamin Iron Zinc. For best results, inject in the fall or in the spring, before the leaves reach their full size. Stemix Plus and Injectamin Manganese are available in 6 milliliter capsules and 1 liter bottles. Injectamin Iron Zinc is available in 6 milliliter capsules. Share your success. You may even want to keep a visual record of your treatments for your files, and Mauget would love to hear your success stories. It's always nice to have a reminder of your successes to show your current and future clients. So take a picture before you treat. Keep good notes on the treatment. What was the issue being addressed? What was the treatment, including where and when? Then go back and take another photo from the same vantage point to create a useful before and after presentation. Now you have something to verify the results for your records. Take an extra few minutes and send that information to info@mauget.com with the subject Before and After, and we will spotlight you and your company on our Instagram page @CaringForTrees. Conclusion. This concludes this presentation. Upon passing the test, you will earn the ISA CEUs listed in the description. We encourage you to watch additional modules so you can continue to expand your knowledge and add to your ISA CEU total. This presentation also included Mauget's recommendations for the treatment of the pests and/or diseases mentioned. Remember, it is important to read the label for the product being used to ensure you have all the information you need before applying the product. Mauget can help you take care of your customers' trees. Be sure you are on Mauget's email list to ensure you receive our monthly bulletins. Mauget has been the right way to treat a tree for over 6 decades. You can count on Mauget to keep you up to date on the latest advances in microinjection. Remember to follow us on social media and join the forums on Mauget Certified to learn what other applicators are doing, issues they may be having, and share your knowledge and experience. We are happy to have you as part of the Mauget team. We look forward to growing together.